Hello everyone, hope you are doing well. I am Akshay Parmar, Assistant Professor at LJ Institute of Engineering and Technology in IT/IC Department. Welcome to the video tutorial series of the data communication and the computer networks. Today we will discuss an error detection techniques. Right, in that we will briefly discuss about the LRC and the CRC. Outline for the today's video is error detection method. First of all, we will discuss about what is error, and after that we will discuss its type. Right, so when the error is occurred, how to detect them, we will see the methods for that. Right, so what is error according to you? So what is error? Error is a condition when the receiver information doesn't match with the sender information. During the transmission, the digital signals suffer from the noise that can introduce an error into the binary bits traveling from sender to receiver. Right? Whenever you are transferring the bit or data from sender side to the receiver side, the noise is encountered and it will introduce an noise into that. Right? So it will modify that signals and the error bits are changed. Right? That means the 0 bit may be the change to the 1 or 1 bit is changed to the 0, right? That's about the error. So when the error is occurred, when a transmission of the digital signal take place between two systems such as the computer shown in that figure, that computer 1 is the sender and computer 2 is the receiver, right? So to get the contaminant due to the addition of the noise to it, right? It is necessary to detect and correct the error, because these errors can become the serious threat to the accuracy of the digital system, right? So here you can observe that the sender has sent the data in the square waveform, right? So by the noise which is included in that, right? So the receiver is not getting the information as the sender has sent it, right? So that's how we need to detect and correct the error, right? So for that we have the mainly three kind of error detection methods, right? So in our previous session we have seen the vertical redundancy check, VRC. We will discuss about LRC and the CRC today. What does the LRC and the CRC stands for? Longitudinal redundancy check stands for the LRC, and the cyclic redundancy check stand for the CRC, right? So let's begin with the today's session, the longitudinal redundancy check, LRC. So what do you mean by the LRC, right? So in a LRC, a block of a bit is divided into the rows, and redundant rows of the bit is appended to the whole block, right? Let's see it by one example, right? So instead of sending a block of 32 bit, we organize that 32 bit into the table made of the 4 rows and the 8 column, right? So we are dividing that 32 bits into the 4 rows and 8 column, right? Then we calculate the parity for each of the column and create a new row of the 8 bit, which are the parity bit for the whole block, right? So let's see it by one example. Let's take an example about, we have the bit sequence 11100, 1111110 and so on, right? So this is our bit sequence which have the 32 length, right? So we have the 32 bit sequence, right? So we are dividing that 32 bit into the chunk of 8 bits, right? And we are organized that in a such a way that first of all we will select the first 8 bit as a one row, second 8 bit from 9 to 16 as a second row, right? So and so on, right? So that's how we are organizing that bit sequence into the 4 manageable chunks, right? We have divided the 32 bits into the 4 rows, and you can observe that it is that 8 column, right? After that we are applying the parity bits there, right? So for apply we are for an example we are taking an even parity bits here, right? So in the first column you can observe that that there are the 3 ones there, right? So make that an even, we in the parity bit we are putting an 1 there, right? So if we put the 1 in the parity bit, then total number of the ones and that particular sequence is 4, right? So we are getting an even parity there, right? So 1101 is the where in that the 3 1 is there, so we are putting in 1 as a parity bit there. After that, in the second column, there are the only 2 ones in that particular column, right? So we don't need to add an even parity bit there, so we are simply putting 0 there, right? Because there are already even number of ones in that column. After that, in the third column, there are the 3 bits there, right? There are the 3 ones bit are there. So make that column even parity, we are putting a 1 as a parity bit there. Likewise, in the fourth column, we are putting an 0 because there are already an even number of ones in that particular column, right? After that, for the fourth one, there are the 3 ones are there. So what we need to do? We need to add an parity bit as a 1 as a parity bit, because by that we are making the number of 1 as an even number, right? So we are putting 1 there. In the sixth column, there are already available 2 bits which is even number of ones, so we don't need to put an 1 there, so we simply put a 0 as a parity bit there. After that, in the seventh column, there are 1 0 0 0 sequence is there, so make that column in the number of ones and even, we need to put an 1 as a parity bit, right? Likewise, we are putting in parity bits there. And in the last column, there are already 4 ones are there, that is even number of 1, so we don't need to add a parity bit, so we are simply putting the 0 there, right? So that's how we have make a sequence of that parity bits 1 0 1 0 1 0, right? So that's how we are getting that information. We have, first of all, we have divided that 32-bit sequence into the 4 rows, right? And that rows have the 8 columns. After that, we have make another row of the sequence, bit sequence of the parity bit there, right? In the parity bit sequence, we are selecting that particular column, and to make an even number of ones in that particular column, we are putting zeros and 1 whenever it is required, right? So that's how we are making a parity bit sequence, right? After that, whenever what is the data plus LRC, right? So whenever that is the data which is already available and the LRC, the bit sequence that we have made, right? So whenever we are sending the data plus LRC to the receiver end, that's how it is sending, right? The first bit sequence is at that place. After that, the second row is appended. After that, the third bit sequence is there, right? And so on. That's how we are getting the original bit sequence which is sent by the sender, right? After that bit sequence, we are adding that bit sequence of the parity bit, right? So the parity bit sequence we are putting after the data, right? So data plus LRC we are getting is this kind of, right? So that bit sequence is sent at the receiver end, right? That's how we are sending the data to the receiver end, right? The receiver, how the receiver is checking that the data which is received is accurate or not. For that, this is the technique about how the sender is appending the LRC bit sequence into the data, right, and sending this bit sequence through the transmission media at the receiver end. After getting that data plus LRC bits, how that receiver is encoding this bit sequence is accurate or not. For that the receiver end, they are also doing the same kind of technique, right? For that they are dividing that bit sequence into the 8 manageable chunks, right? So the first bit sequence is selected as the first row, second bit is selected as the second row, third bit is selected as the third row, fourth bit sequence is selected as a fourth row, and the last 8-bit sequence is selected as a bit parity bits, right? After putting that, at the receiver end, they are checking about that parity bits are similar or not, right? So when the receiver checks the LRC, some of the bits do not follow the even parity rules and the whole block is discarded. In that, at the receiver end, that's how the receiver is checking about the parity bit, right? So whenever that even parity is not fulfilling in that any of the column, then we can simply discard the whole block of the sequence, right? So for an example, right? So you can check that in the first column there are the 4 number of ones, so it is already following the even parity number. The second column has the 11000, that is also an even parity. The third column 10111, right? So there are the 4 number of ones there. After in the fourth one 0111000, the 2 numbers of ones is there, so even number of 1 is already there. In the fifth one 01111, so there are also 4 number of 1 there, which is following the even parity. That's how the 6th, 7th and 8th column that we are checking about the parity, and they are following the even number of ones or not, right? If we are following the odd parity there, so we can calculate about the odd parity checking, right? So that's how we can confirm about the data is sent by the sender is received properly or not. The major drawback about LRC is if the damage bits are exactly the same position in the two data units, then LRC checker will not detect an error, right? For an example, let's have a bit sequence about that. In the third column we are changing that 0 and 1 to the 0 and 1, right? So we are changing that bit 0 to the 1 and that bit 1 into the 0, right? So if we are changing that bit sequence, we are getting the new bit sequence, right? That bit sequence is not correct, but whenever you are checking that the bit sequence is following that rule or not, so in the LRC bit checking that column is following the even number of parity, right? 11011, right? So there are the 4 number of ones is already there, but initial state was what was that 1011 and 1, right? That was our actual information, but somehow the data is modified at the 2 data unit, so we cannot forget about the data is modified or not, right? So that is the major drawback about the LRC technique, right? So let's move forward about the CRC technique. This is the type of the polynomial code in which a bit string is represented in the form of polynomial with the coefficient of the 0 and 1 only. The polynomial arithmetic uses a modulo 2 arithmetic, right? For an example, addition and the subtraction are identical to the XOR gate, right? For CRC code, the sender and the receiver should agree upon the generator polynomial g of x. A code word can be generated for the given data word, for example message, polynomial mx with the help of long division. This technique is more powerful than the parity check and the checksum error detection, right? So after that, the CRC is based on the binary division. A sequence of redundant bits called the CRC or CRC reminder is appended at the end of the data unit such as the byte. The resulting data unit after adding the CRC reminder becomes exactly divisible by another predetermined binary number. At the receiver, this data unit is divided by the same binary number. There is no error if the division doesn't not yield any reminder, right? But a non-zero reminder indicates the presence of error in the receiver data unit. Such an erroneous data unit are then rejected, right? So that's how we are checking the data is corrected or the code are generated by an adding of a group of parity bits or a check bits. The source generates the binary data which is accepted by the encoder to add the check bits and then produce the code word. The check bits are used by the decoder to detect and correct the error. The encoder adds check bits to the data bits according to the prescribed rule. Decoder uses the parity bit to detect and correct the errors after separating the data and the check bits, right? The data bits are then applied to the destination, right? That's how the CRC is working. You can observe that is the data source, right? At the encoder side, the data bits is added and we are getting the code word, the data bits and the check bits, right? After that we are sending the data bits plus check bits, the code word to the receiver end. At the receiver end, the data is fetched by the decoder, and the decoder is decoding and dividing the data bits and the check bits, right? And after the discarding that check bits, the data bits are sent to the destination, right? That's how the data is sent from the source to the destination in the CRC mode. So this is all about the CRC technique. In this today's session, we have discussed about what is error and its detection methods. In that, we have briefly described about the LRC and the CRC, right? So that's all about today's session. Thank you for the watching.